Presentation is represented by electrical4u.com, an online electrical engineering study site. Today's topic is laws of thermocouples. Let us take two dissimilar metals M1 and M2. One strip of metal M1 is shaped as you see here. Two smaller strips of metal M2 which are shaped as you see here. Now connect these three strips in the way as shown here. There are two bimetallic junctions formed. One is this one, and another is this one. Now this junction is heated by this candle flame. And this junction is immersed in this ice water. Now we will connect one sensitive multimeter, as shown here. You see, this meter is giving some reading. This is nothing but the voltage between these hot and cold junctions. Now if we increase the temperature of the hot junction, by increasing the intensity of the flame, we will see the reading of the multimeter also increases. This proves that the voltage between these two junctions is the function of temperature difference between them. A German physicist named Thomas Johann Seebeck has discovered this effect. His discovery is called the Seebeck effect, and it is the basis of all thermocouples. We have three different laws of thermoelectric circuits. These laws are known as law of homogeneous circuit, law of intermediate metals, and law of intermediate temperatures. The first law, homogeneous circuit, states that in a circuit composed of a single homogeneous metal, cannot generate an electric potential by the application of even sufficient temperature difference between two different points of the circuit. Here the temperature of this hot junction is T1 and temperature of cold junction is T2. There is a temperature difference between these two junctions, and that is T1 minus T2, but still the multimeter gives zero reading, as the junctions are made of same metals. The second law is also known as Thermocouple law of intermediate metals, states that the net EMF in a circuit consisting of interconnections of a number of unlike metals, maintained at the same temperature, is zero. That means, if other metal conductors are inserted in the thermocouple circuit and the junctions of these interconnected metal conductors are in same temperature, then output EMF will not be affected and remains same as if it was made of only two metals. Then come to this circuit. Here T1 and T2 is the temperature of hot and cold junction respectively. Now take the reading of the multimeter. Here this third metal is inserted here in the circuit. This creates new two junctions in the circuit. If T3 is the temperature of both new junctions and T1 and T2 is the temperature of hot and cold junction respectively. Now again take the reading of the multimeter. In these two cases you will see the multimeter reading is same, which proves the statement Thermocouple law of intermediate metals. The third law, successive or intermediate temperatures, where EMF E1 is generated when two dissimilar metals have junctions at temperatures T1 and T2 and EMF E2 results for temperatures T2 and T3. It follows that an EMF E3 results at output terminals when the junctions are at temperatures T1 and T3. Here, E1 plus E2 equals E3. Thank you. Hope you got a clear and basic idea.
Is it okay?
Yes, sir.
Okay. And now, let's we move forward for the next type of a thermocouple. We call it a thermistor. Now, this thermistor, the title of this thermocouple is the combination of two words. One is a thermal.
Sir, screen is not visible.
Okay. Now?
Yes, sir, visible.
Okay, so now this is the next type of a thermocouple. If you try to read it, the title name of that thermocouple is a thermistor. Actually, this thermistor name is the combination of a thermal and resistor. So you can find it, thermistor. Is it right? So in this way, the name it is decided. It means that this is a one type of a resistor whose resistance is depends upon the thermal energy. It means that heat energy, temperature. Due to the temperature, if the resistance of the resistor is going to be changed, then it is called as a thermistor. This is the basic things related to this thermistor is there. And now, please try to read it. The term thermistor is the combination of thermal and resistor. So, thermistor is a resistor with the important thermal characteristics. Thermistors are thermally sensitive resistors whose prime function is to exhibit the large, predictable, and precise change in electrical resistance. It means that due to the thermal energy, the resistance of that thermistor is going to be changed when subject to the corresponding change in a body temperature. And now, as I say that thermistor is a one type of a resistor. So this is a symbol of a resistor. It's a type. And now see that the symbol of the thermistor, it should be like this. And the T is overwritten here. Why T? Because as the temperature is going to be varied, it's a resistance of that resistor or the thermistor is changes. That is called as the thermistor here. If you see that the construction of the thermistor, then you can observe that. Have you observed that this rectangular part in that diagram, that rectangular part is nothing but a one thermistor material. Then which thermistor material is used? Any. Why I say that any? But the thing is that that material shows the property as the temperature changes, its resistance must be changed. जर कुठल्याही मटेरियल जर ही प्रॉपर्टी दाखवत असेल तर you can use that material for as an thermistor material for the construction of a thermistor here. It means that as the temperature changes, the resistance is also going to be changed. मग आता याच्यामध्ये दोन केसेस येऊ शकतात. As the temperature changes, the resistance is either increases or decreases. It is the property of that material. आपण कोणतं मटेरियल थर्मिस्टर कंस्ट्रक्ट करण्यासाठी यूज करणार आहोत, based on that, in between the temperature and the resistance, the two cases are there. Depends upon the temperature, either resistance of the material is increases or decreases. Get it, my friend? So such types of material is used as a thermistor material. This material, it will be connected with the two connecting rods. We call it contact leads. These are the two terminals of the thermistor. As this is the A terminal, this is the B terminal. Similarly, this is the A terminal, this is the B terminal. And this entire construction is encapsulated with that another one material. It can be shown with this oval shape base material is that. So this is the basic construction of the thermistor here. And now you can read it which material is used. The thermistors are made up with the various mixtures of metal oxide such as manganese, nickel, cobalt, iron, etc. As I already said that any material who shows the property based on the temperature and the resistance is that. So any material we can use for the construction of the thermistor here. And as I say that the effect of temperature on that material resistance is either increase or decreases. Based on that, the thermistors having its two types. So what are these two types? The one is the positive temperature coefficient thermistor and another is negative temperature coefficient thermistor, PTC and NTC. Then what is the difference between that PTC and that NTC? Have a look on it. Okay. If temperature increases, the resistance of this material, if it is increases, then it is called as a PTC. Okay? जर टेम्परेचर वाढवलं तर रेजिस्टन्स पण वाढवतो and vice versa. जर टेम्परेचर कमी केलं तर रेजिस्टन्स पण कमी होतोय. याचा अर्थ काय झाला? The resistance of the resistor or the resistance of the thermistor, if it is directly proportional to the temperature, then such types of transducer is called as a PTC types of a thermistor. And exactly reverse, if temperature increases, its resistance is decreases, or if temperature decreases, its resistance is increases. It means that I say that if the resistance is inversely proportional to the temperature, then such types of thermistor is called as a negative temperature coefficient of the thermistor. Now please have a look on it. See that a PTC thermistor increase the resistance as temperature rises. Very important thing. The relation between the resistance and the temperature is linear, as expression given by change in resistance is directly proportional to the change in a temperature, where delta R is a change in resistance, delta T is a change in temperature, and K is the temperature coefficient, which is constant. So here we can say that if the resistance is directly proportional to the temperature, so definitely we will have that the linear curve. Get it, my point? And the graph should be like this. It's a linear. This one portion we call it a linear curve. So this is called as a PTC type of a temperature. म्हणजे जर resistance हा directly proportional असेल. Now for what purpose? What are the application of a PTC type of thermistor? See that. The PTC thermistors can be used in place of fuses for the circuit protection. आता मला सांगा फ्यूज कशासाठी यूज केली जाते? For our domestic purpose, we use that fuse. As we know that if over current, it flows through the main wire, main supply, then this overcurrent will damage that appliances, whatever that appliances we use for our domestic purpose. And to avoid these things, we use that the fuse. When overcurrent it flows through the main wire, the fuse wire it will melt due to the increase in a temperature. कारण current flow होतोय म्हणजे heat radiate होतोय आणि heat in the form of temperature. मग जर overcurrent flow झाला तर त्या fuse वायरचं temperature increase होतं. Temperature increase झालं की ती fuse wire it will be melt. It will be melt and the circuit becomes open. आणि एकदा circuit open झालं की current हा काय होतो? Cut होतो, zero होतो, and our domestic appliances will be safe. In this way, we can avoid the damage of our domestic appliances due to the overcurrent by using the fuse here. Now, in place of fuse, if we use that PTC type of a transducer, आता बघा काय होऊ शकतं. जर overcurrent flow झाला, means current it will be increases. Definitely the temperature of that wire is also increases. As temperature increases, PTC resistance, thermistor resistance is also increases. And if the resistance increases, then what about the current? Definitely current it will be reduces. It means that PTC temperature will reduce that overcurrent and will avoid the damage of that domestic appliances is there. So this is the application of PTC type of a thermistor here. Get it, my point? दूसरा application देतो बघा. We use that the television. We say that it's a TV. Is it right? If this television is operated continuously for 2 days, 3 days, 4 days, 1 week, continuously without switching off, what happened? Definitely the temperature of the component which is used in the television will be increased. And if the temperature it goes beyond the certain limit, the component will be burned out. And when the component it will be burned, definitely our television will be damaged. So to avoid these things, a PTC type of a transducer when I used. आता इथं PTC चा use बघा. If the temperature of the television component it will goes beyond the certain limit, then definitely the resistance is also goes on increasing. आणि जर आपण असं सर्किट तयार केलं की जर टेम्परेचर it goes on increasing after certain limit, then definitely the circuit current it must cut. It means that the television it will be automatically off. And this use of the PTC, if the temperature of the component is goes beyond a certain limit, it will sense and it will cut the television power automatically. It will save the television from the damage. In this way, the PTC type of a transducer it will be used, and there are so many applications are there. Now I hope that you will get that what is the use of the PTC type of a transducer is there. So these are the application is there. Now what you can remember that in the PTC type of a transducer, as the temperature is increases, the resistance is also increases is there. Then this property, in which way you can use in actual circuit, it's your choice is that how to use this property of the PTC type of transducer. Get it, my point? And now the second type we call it an NTC type of a thermistor, means a negative temperature. Now you can try to read it. NTC thermistor decreases their resistance as temperature rises. It means that its relation is inversely proportional. And this is the graph. It's a inverse. As temperature increases, resistance is decreased. So this NTC thermistors, on the other hand, are used for the current limiting resistor. Is it right? Now see that what are the application of that NTC type of transistor? It can be used as a current limiting resistor, or it can be used in a digital thermostat or automobiles. मग आता आपल्या घरामध्ये, if you know that we use that the refrigerator, is it right? So what is the actual function of refrigerator? The refrigeratorचं function जर बघितलं तर तुमच्या असं लक्षात येईल की रेफ्रिजरेटरचा सप्लाय हा कायम ऑन नसतो. बरोबर आहे. जर रेफ्रिजरेटरचं टेम्परेचर वाढलं तर सप्लाय हा ऑन होतो आणि सप्लाय ऑन झाल्यानंतर टेम्परेचर हे रिड्यूस केलं जातं. एका सर्टन लेवल पर्यंत टेम्परेचर रिड्यूस झालं की रेफ्रिजरेटर सप्लाय हा ऑटोमॅटिकली ऑफ होतो, कारण टेम्परेचर हे कूल झालेलं असतं. बरोबर आहे. एकदा टेम्परेचर एक सर्टन लेवल पर्यंत आपण सेट केलेलं असतं, त्या लेवल पर्यंत आलं की सप्लाय हा तुमचा काय होतो, ऑफ होतो. पुन्हा काही वेळानं टेम्परेचर काय होतं, वाढलं जातं. टेम्परेचर वाढलं सर्टन लेवल पेक्षा की पुन्हा सप्लाय हा ऑन होतो. अशा प्रकारे आपल्या रेफ्रिजरेटरचं फंक्शन्स असतात. आणि त्याच्या त्या ठिकाणी एक मेन सेन्सर यूज केला जातो, तो आहे एनटीसी टाइप ऑफ थर्मिस्टर, आणि एक रिले यूज केला जातो. With the help of these things, it is possible to operate the thermistor. It is operate at the refrigerator. म्हणजे टेम्परेचर वाढलं की तुमचा सप्लाय ऑन झाला पाहिजे, म्हणजे रेजिस्टन्स कमी झाला पाहिजे. रेजिस्टन्स कमी झाला की तुमचा करंट वाढणार, करंट वाढला की तुमचं टेम्परेचर काय होणार, रिड्यूस व्हायला कमी. इन दिस वे एनटीसी टाइप ऑफ अ थर्मिस्टर इट इज यूज्ड. Is it that clear? Okay. And now today with this discussion, today we are going to stop here. So only one type of a thermistor it's remain. We call it a photoelectric pickup, and definitely we will try to discuss this last type of a thermistor in the next session.